Well, you're welcome back. This is a question, an IGCSE chemistry. This is the code 0620 code chemistry. And this is a question based on protecting the cathode made of what? Steel. Made of what? Steel. You know, there are two methods of preventing steel rusting. It could be sacrificial protection or cathodic word protection, right? So I have a question, two questions, this and this very well. Now look at this diagram closely. Without this information given, is this cathodic protection or sacrificial protection? This, it is not what? A cathodic word protection using an inert electrode. Rather, it is what? Sacrificial, because there is no what? Battery. There is no power supply. So this one definitely what? Sacrificial what? Protection, because there is no battery or power supply that pumps the electron around the circuit, or there is no inert what? Anode, right? Now the diagram, if you look at it, we have block of magnesium, we have disconnected logically to the steel pipe, right, via the cable to the steel pipe, the body of the steel pipe. Now if you look at this very one of them is the anode and this is the cathode. Which of them is the anode? And how do you verify that? Now, magnesium, the steel pipe is a mixture, it's an alloy. It's a mixture of what? Iron and what? Carbon. So, if you look at magnesium, that's a symbol. Magnesium and iron, these are the metals. So, the one that is more electropositive, or the one that is more reactive in the reactivity series, will be the anode. The one that is less reactive would be the what? The cathode. This is the reactivity series of metals, right? This from potassium up to gold. Now look at magnesium. Magnesium is on top, iron is down. So electron, the one on top, right, of the series, they're the more reactive one, right? So magnesium is more reactive than iron. So electron will flow from the more reactive element to the less reactive element, right? If it's aluminium and iron, flow from aluminium to what? Iron. If it's zinc, zinc to iron, right? Now, you know, when you're protecting the cathode made of steel, you use either magnesium, aluminium, or zinc. So electron flows from the more reactive one to the less reactive one, right? That's how that. Therefore, magnesium becomes what? My anode, and this becomes my cathode, right? Good. Now, electron will not flow. This is the electron flow direction, flow from here and it goes in there. Now the question that follows, give an explanation in terms of electron transfer why the steel does not rust. Why the steel does not rust, right? Just simply write electrons move or flow from magnesium to steel, right? No oxidation of iron in what? Steel. Simple as that. Electron move or flow from magnesium to steel, no oxidation of iron in steel. You know, since the steel is accepting or gaining electron, it will not be oxidized. But if this iron is the one that loses electron, the steel pipe loses electron, then this will what? Rust, right? This will rust. That is, if you make here, if you connect here, right, and copper, this is more reactive than this. This becomes the anode. This becomes the cathode, or this and this. So electron will not flow from this to this and this. If electron flow, electron lost by iron to lead, or electron lost from iron by iron to copper, this will not be oxidized, then therefore this one will now rust. So since electron is not moving from iron, therefore this is what preserved, this is what conserved, right? Right, where electron flow from, the metal becomes what? Used up, goes into what? Solution, right? So no oxidation of iron in what? Steel. right? And this is actually the reaction. If you look at magnesium here, magnesium block will lose electron. 2A2 lose its valence electron. Then you have magnesium, right? It's an oxidation process. That's electron. Minus means electron lost. So it flows from magnesium. It goes into what? The steel pipe. Now, the second question. This question, of course, is about cathodic protection because of the power supply and the inert anode. The inert anode. That's the major difference between sacrificial protection and cathodic protection. Cathodic protection has a power supply that pumps the electron, and it has an inert anode. Unlike cathodic protection, there's no battery, no power supply, and the anode here is not inert, right? This is a reactive metal. Platinum is, if you look at platinum is very resistant to corrosion, right? Okay. The second question, you can find, let me explain the diagram. This is the cathode, and this is the anode. So this is the electrolyte, the seawater, and this is the power supply. You can find bubbles of hydrogen gas. Now, you can also find bubbles here, right? Bubbles of gas. But this question is pertaining to hydrogen. Now, write an equation for this formation of the gas, right? The gas referring to hydrogen gas, given up at the steel cathode during cathodic protection, or during this it's electrolysis, right? Because of the power supply. Definitely the electrolyte here will be broken down by the flow of current. It's actually an electrolysis process. Now, write an equation for the formation of the gas, and that gas refers to hydrogen. Where is this hydrogen from? Seawater has dissolved salt, so the water there, these are the ions. So the hydrogen that is formed here is from the water. And if the circuit, if you look at the circuit setup, if it's closed or complete, right, when current is flowing, therefore this will now be attracted. It will now be attracted by the cathode. Or cathode will attract hydrogen ion. Cathode is the negative electrode, right? That attract cation. This is also cation, right? This is called cation. Possibly charged ions move to the electrode of opposite charge. That is this, right? This is the cation. So it's C for C. Now, when hydrogen ion get to the cathode, it is now discharged as hydrogen gas, But how do you achieve that? Actually, hydrogen, if you look at hydrogen, we remove an electron, hydrogen ion, electron from the cathode, and it becomes hydrogen atom. Also, hydrogen, also remove an electron from the cathode, right? Or gain electron from the cathode. This electron plus must means gain, right? Or accepted. Now, if you sum it up, you have this. This is the equation, right? So if you look at this, the two electrons that is accepted, right, is from the cathode. This is from cathode, right? So that is, it flows. Electron flows out from the battery and it goes into, so the electrons accepted by the hydrogen ion. These two ions will be here, right? The electrons then will now pair up H plus to give you the gas. That's the gas you are seeing there. So the equation, this is just the equation, this is just to get this, right? This is what they need, this equation, this very one. So you write 2H plus 2E, give you this. Or you can simply write 2H plus H this minus 2E. This is the gas, right? So don't forget, this is the gas and this is the gas. Either of this is correct, right? Now, The next question, give one difference between the two methods. There are a lot of differences between what? Cathodic protection and what? Sacrificial what? Protection. Sacrificial what? Protection. There are a lot of differences between them. So if you look at this, these are differences between what? Between sacrificial protection and cathodic what? Protection. Right? If you look at this one closely, you will see that sacrificial protection is an electrical what? Cell. Right? Cathodic protection is electrolysis, not an electrical what? Cell. The second difference, electrons flow from the more reactive metal, which could be magnesium, aluminum, or zinc. Electrons flow from the battery, right? The third difference, it does not need a power supply. That is what sacrificial protection. It is invariably a spontaneous what? Reaction. It can start on its own without the battery. It needs a battery or a power supply. And the last one is, it uses up the anode. The anode is sacrificial protection, be it magnesium, aluminum, or zinc, is what used up, right? So it need to be periodically replaced. After some time, you need to replace the anode, right? The electrode is not used up, right? Because the electron is what? An inert what? Anode, right?